Hey, Miss Marion here. We are going to go over lesson 3. So make sure you go ahead and get your workbook out. You're also going to need a paper, like a copy paper. So today we're going to be talking about graphing proportional relationships, what they're going to be. By the end of today, you'll be able to scale and label a coordinate axis and able to go ahead and do the proportional relationship, graphing it. So that's what our goal is for today. All right, on page 21, sorry, I didn't change that one. Let's go ahead and do these. So 15 times 2, okay, grab a calculator. Well, that's 30. 15 times 0.5, okay, that's 0.75. 15 times 0.25, that is 3.75. And then 15 times 2.25 is 33.75. So getting our brains warmed up as far as math and different things and just kind of doing that general kind of stuff. All right, so let's go ahead and let's turn to page 21. And it says, number 1, here are 2 ways to represent a situation. Jada and Noah counted the number of steps they took to walk a set distance. Jada took 8 steps and Noah took 10 steps. And they found out that after Noah took 15 steps, Jada took 12 steps. So notice how we have all this information here. This is one way of actually looking at it. And then also they have, say, let the equation x represent the number of steps. And then they have this equation that's here. So eventually what we want to do is we want to go ahead and we want to graph this situation. But what we're going to do is on page 21, you need to write down tails. And tails is everything that I'm going to be looking for in a graph. So T is title, so some type of title. A is axis, so the axes are labeled. I is interval, you have the correct intervals that go along. And this is the same stuff that science has done, if you're recalling it. L is we have labels going on. And then we have our scale. S is scale, our scale is correct. So these are the things that I'm going to be looking for when we're actually graphing the graphs. Go ahead and write this down somewhere on page 21 so you remember what we're actually looking for. So go ahead and pause this video, write it down, and make sure you have it so then you can do this correctly. All right, so again, we want to go ahead and let's create a table. The table is really going to go ahead and help us. So also on page, sorry, I didn't change that, should be on page 21. We're going to go ahead and write a table that goes along with this situation. So both the equation and the table work for Jada and Noah's situation. All right, so you want to go ahead and write this table on page 21. And our table, yes, we're going to have our X. We're going to have our Y. X is Jada. Y is Noah. So when Jada took 8 steps, Noah took 10 steps. And then when Jada was 12, Noah was 15. So what we're going to do is we want to go ahead and we want to find our slope. Right? We were doing slopes a little while ago. So our slope is our vertical over horizontal. So remember, it's the change of y over the change of x, right? So how do the y's change? Notice how this goes up by 5. And then how does the x's change? Well, notice how this goes up by 4. So our slope is 5 over 4. So notice how this 5 over 4 is the same slope that we just went ahead and found. So notice how the table and the equation go together, and then we're also going to go ahead and use this to go ahead and graph the situation. So what we want to do, also on page 21, we have this graph. We want to take this situation and we want to go ahead and graph this situation on this graph that we have on page 21. Remember, we're going to follow tails, right? And T is title, right? So we need to come up with a title for this situation. So who are we talking about? We're talking about Jada and Noah, and we're talking about their steps. So I'm going to say Jada and Noah's steps. So this tells me exactly what I need to go ahead, like if I look at it, I know exactly what this graph is about. And I'm going to move this up a little bit. So remember when we had our table, we had X was Jada, Y was Noah. So we have it as down on the bottom for the x-axis is Jada's steps. And then a Y is Noah's steps, right? And then remember on our table looked like so we had 8 and 10, and then 12 and 15. So we want to go ahead and graph this, right? So we want to come up with a scale for Jada. Notice how Jada's is 8 and then 12. Notice how these are even. Could we come up with an idea to go ahead and label these things? I could do it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That actually might work. We could also probably label it by 2, like 2, 4, 6, 8, 10, 12, 15, 16. And then we can also label it by 4. I think the 2s is going to work the best. So let's go ahead and let's label the bottom part. So this is kind of our scale. We're going to have it as, let's do it by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then 26. Okay, and so that's Jada, right? Let's look at Noah. Notice how Noah's, this is 10 and this is 15, right? These are kind of going up by 5s. Could we label it by 2s? Yeah, but it will be a little bit hard. We would have to go like in between on the graph itself. So I think we need to go ahead and we need to label these by 5s. So let's go ahead and do that. So we are taking it and we're going to go ahead and label it 5. So 5, oops, sorry, I need a pen. So we have 5, 10, 15, 20, 25, 30. You should be doing this with me, so write it down on your thing. 35, 40, 45, 50, 55, 60, 65, right? So now we have different scales for Noah and Jada, and that's totally fine. It has to do with the numbers that are actually given to us. Now, let's go ahead and plot these points. So the first point, if you look at it over here, we have 8, 10. So we're going to go over 8, up 10, put a point. And then we have 12 and 15, like so, right? So my question is, at the beginning, does Noah and Jada have any steps at the beginning? So if they're counting the number of steps, they're actually going to start at 0, 0. Because they didn't say, oh, we are already started to count, we're going to begin to count. So notice how it's going to start at 0, 0. And then notice how, let's see if I can draw that a little bit better. This would be our graph. Here are some other examples of the graphs that we have. Okay. And so, but make sure you have it in your workbook. So using the graph that we just really had, let's answer on page 22. It says, letter C. So how can you see or calculate the constant of proportionality in the representation? So what is the constant of proportionality? Well, the constant of proportionality is actually the slope in a proportional relationship. All right. So what's a proportional relationship? Proportional relationship is where a line goes through 0, 0. Notice how our line does go through 0, 0, and we want to go ahead and find our slope, right? And that's actually what we're looking for. So we can actually make a slope triangle. Notice how I was using the 8, 10 point, and I made my slope triangle. My vertical, what is my vertical? My vertical is 10. My horizontal is 8. So then my slope would be 10 over 8. Well, is this my final answer? No, it's not, Miss Marion, right? We need to go ahead and simplify it down. Both numbers are even. So I'm going to divide it by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. So the constant in proportionality is 5 over 4. Now it says, okay, what does it mean? So 5 was the Y stuff. 5 was Noah's steps. So for every 5 steps of Noah, Jada has 4 steps. Okay, and then, so that is on the table. So that's how we find it on the table, right? How do we find out, or sorry, that's on the graph. How do we find on the table? Well, we kind of already did that, right? So this is up by 5. This is up by 4. Then our slope is going to be 5 over 4. So notice how all these things actually come together. The graph and the table and pretty much the story all come together and are actually showing the same kind of thing. Noah and Jada's steps. For every 5 steps Noah goes, Jada only has to do 4. All right, so on page 22, we have another situation. So we have Origami Club is doing a car wash fundraiser to raise money for a trip. They charge the same price for every car. After 11 cars, they raised $93.50. After 23 cars, they have $195.50. So notice how we have the words, right? And then notice how it went into a table. So right now we want to write in an equation that goes along with this situation. So it's kind of like Noah and Jada. Think about it, right? So I want you to write an equation for this situation. So pause and then come back to me. All right, so let's go ahead. We need to find our slope. So number of cars is our X value, right? And then the Y value is the money raised. So how do we find the slope between the, going from 11 to 23? So we can do 23 minus 11. All right, so that's 12. So it's adding by 12. And what about the other part? So we can go 195, 50 minus 93, 50. How does that change? Notice how this is adding 102. So how do we find our slope? So I'm going to move this up because I need more room. So our slope, again, is our change in the Y over change in the X. Let's put that together. So how does the Y's change? 102. How the X's change? By 12. So let's go ahead and let's see if this will simplify down. Well, I know both of them are even. Let's divide the whole thing by 2. Let's do 102 divided by 2, and we get 51. Let's take 12 and divide it by 2, and we get 6. So 51 over 6. So 51 is prime. 6 is even. Can I simplify it any further? No. So I'm going to have 51 over 6 is my slope. I did forgot to explain something. Notice how my X value, I have it as the number of cars. In science, we were talking about different things. This would be the independent variable. Okay. So does cars depend on money or does money depend on cars? Well, the money is going to depend on how many cars they wash. So remember that independent is the X value, dependent is the Y value. And that's why I have it as the X and the Y. And then that's how I also got my slope. So we do have it as 51 over 6. So that is our slope. Eventually we want to go ahead and write an equation. We are dealing with money. So in this situation, let's go ahead and divide 51 divided by 6. And then what do we go ahead and what do we get back? That is $8. So that is $8.50 over 1. So what does that mean? So for every car, because that's the Y, that we wash, they get $8.50. So then let's go ahead and, so we have our slope, right? This is our slope. And we want to go ahead and we want to write an equation. So my question is, where does this table start? So think about it. If we do not wash any cars, we're not going to have any money. So this is what is considered a proportional relationship. And this is actually what we did in 7th grade. Remember, the proportional relationship is y equals kx. And the thing that we need to remember that k is what is considered the constant of proportionality. Now remember, what is that? Well, that's also a fancy word of a slope of a proportional relationship, or a slope of a graph that goes through 0, 0. So let's go ahead. Let's put all of this together. Let's go ahead and write the equation. So we're going to have it as y equals, remember k is my slope. Oh, what's my slope? It's $8.50 over 1. So we're going to put the 850 in there. So 850. And then remember, it's going to sit next to x. So x is an indicator. Hey, by the way, the slope is sitting next to me. But this would actually be the equation. Let me put that in black. Okay. So this is the equation of the situation of the origami club washing cars to make money. So every car that they wash, they get $8.50. So the one thing that we need to go ahead and look at also is notice how they want us to use C for the number of cars and M to represent the dollars. So let's go ahead and put that piece of information in there too. So C was the number of cars. Cars was which value? Oh, that was X. So I can go ahead and have it as equals 850. C was the X, so let's put C in there. And then Y was the dollars, so I can say dollars. Not the word wise. We'll just put D in there. So they want us to put D. And it is the, oh, sorry, M is the dollars for raised in there. So this is also another way of writing that same equation, just with the fancy letters that go along in it. So both of these equations mean exactly the same thing. We just have different letters in there. All right, so we're going to actually take this situation and we want to go ahead and we want to graph it, right? So if we have it, so remember, we had, you guys already have this. So we have X, we have Y. X was the cars, right? Y is the money. We need a title. All right, so what kind of title can we come up with? We are going to say money earned by washing cars. All right, so for every car, we get $8.50, right? So we do have, if we think about it, we did have that graph. And we did have that table. And the table can go ahead and help us to go ahead and graph. And that's what we're looking at. So our table, remember, is 11 and 23. We have 93, 50. And then we have 195, 50. And then remember, our equation is y equals 8.50x. So for every car that we wash, we get $8.50. So I want you to come up with an idea to go ahead and graph the bottom. And then at like number wise. And then I want you to come up with an idea for like the X value, X axis, and the Y axis. And then go ahead and graph it. So go ahead and pause for a second. Go ahead and make your graph, and then I'll show you what I have. All right, so there's a couple of graphs. Here is this first graph. So notice how on the bottom, it just goes up by 2s, and then these go up like by numbers by 20s, because remember, one of the numbers is 193. Right now, these are kind of being estimated as far as where those points are. Here is another graph that I had another student go ahead and do. Notice how these are just numbers of cars that are being washed. And notice how it goes up by 850. So 850, 2550, 4250, 5950. So pretty much every one it goes up by 850, but they only labeled it every other. This also works. And then notice how there's also this one here. Again, this is pretty much done by just number of cars, and then money earned. So again, it's done by 20s. But what I need you to do is, if you have not made your graph, you need to copy down one of these graphs on there so you actually understand how to graph a proportional relationship. That was actually one of our goals for today. So you need to pause, go ahead and pause, and you need to go ahead and draw this on there, and then make sure you have a title. So in fact, these don't have a title on there. And remember, our title is money earned by washing cars. All right, so again, what we're doing is we want to find that constant of proportionality, right? So what is a constant of proportionality? Remember, this is a slope for a graph that goes through 0, 0. Notice how this does go through 0, 0. At the beginning, they didn't wash any cars, but they didn't have any money earned. So that's why it goes through here. Well, we need to go ahead and find the slope. Can we find the slope with the graph? Yeah, we can go ahead and pick 2 points, go ahead and draw that slope triangle. But remember, this graph actually came from this table. So again, how do we find the table that goes along, the slope that goes along with that table? Well, we can do 23. So how do the x's change? 23 minus 11, which is 12. How do the y's change? We can do 195, 50 minus 93.50, which is changed by 102. And then our slope is our vertical, or the x values, which is 102 over 12. Grab your calculator. Let's do 102 divided by 12. And what do we get? Oh, we get that $8.50. So, and it says, okay, what does it mean? Well, let's go ahead and let's label that slope. So we have remember our y values is in dollars. So let's go ahead and label that. Our x value is in cars. And remember, we're going to put this over 1. And the reason why, because it actually kind of tells us what's going on. What is going on with this? For every car that is washed, the origami people, they got $8.50. So notice how the graph and the table and all of this go along with the same thing. We've got the same answer that we did before. All right, so you're going to be given, you should actually have a piece of paper that is copied off, and we're going to be talking about proportional relationships. So this is our paper that we have. You should have this paper. We're going to talk about problem 1, and then we're going to also go ahead and talk about problem 2. So make sure you have this paper, and eventually it does get actually taped into your workbook. All right, so problem 1, we want to go ahead and we want to talk about sketching stuff for honey and then also with flour. So we want to make a graph. We want to go ahead and label that graph. We want to look at it. Well, right now, do we have anything? Can we go ahead and do this at all? Well, not really. So what we need is we need a table like we did before. Like when we were talking about the cars and the money that was earned. We need a table. We need information. So let's go ahead and let's talk about the honey and the flour. And on the bottom part of your paper, you have a table. And the table is kind of like this. It has the honey and it has the flour information. So for 27 grams of honey, we need 6 cups of flour. And for 45 grams of honey, we need 10 cups of flour. So the G is grams, and that's an S, and C is cups. Okay, you now have enough information to 1, find your slope. So right now you're going to go ahead and find your slope. You're going to go ahead and write your equation. And 3, you're going to go ahead and make a graph. So these are the 3 things we want to go ahead and do. All right, let's find our slope. So again, we need to go ahead and then I'm going to go ahead and tell you, we're going to set it up as the honey is our X value and Y is our flour. Could we set it up the other way around? We absolutely could. I'm just going ahead and saying that X is going to be our honey, and then y is going to be our flour. And I'm going to move this up because I need more room. And so let's go ahead and let's find, how do the x's change? How does the honey information change? So we have 45 minus 27. We've been doing this for a while. Okay, so this is adding 18. And how does the flour change? This is adding 4. So how do we find our slope? So remember, our slope is the y stuff over the x stuff, right? How do the y's change? That is 4. How do the x's change? That is 18. Okay, so now we have 4 over 18. We want to go ahead and reduce this. So how does this go ahead and reduce? Well, they're both even, so we can divide both by 2. So we have 2 over 9. So our slope is 2 over 9. Okay, so we need to write an equation. Remember, the equation is y equals kx, where k is the constant of proportionality. It's also the slope. Okay, so let's go ahead and put this all together. So we're going to have y equals, put in your slope, which is 2 over 9, and then we still have the x sitting along there. And then now we need to come up with an idea to go ahead and graph this, right? So again, let's put our labels in. So we're talking about honey and flour, right? And this is to go ahead and for baking, needed for baking, right? Let's label our x-axis. Our x-axis is honey. Our y-axis is, and honey is done in grams. Let's put the grams in there. And then y-axis is flour. Also done in cups. You should be drawing this yourself. And we need to figure out how to label each different tick mark, right? So if we look at the honey, notice how it's 27 and we have 45. So I personally, for the honey, I'm going to label it by 5s because we do have that 45. So, and I'm going to label every one. So notice how I have 5, and then I'm going to do 10. We have 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and then 65, 70. And then I noticed with the flour, well, there's 6 and there's also 10. And I can also label it by 2s if I wanted to, but if I just do 2s, it's going to leave it really, really short down here. I'm going to label it by 1s. So I'm going to say, starting at the beginning, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and up here is 14. Let's go ahead and plot the points that we have. So our first point, and I'm going to put that in green. Notice how it's 27, 6. So 27, I'm going to kind of have to like go over to 25, go a little bit over, but it can also come all the way up to 6. So I kind of put it here because it's in between the 25 and the 30. And then my other point, let's put that one in pink, is 45 and 10. 45, go over to 45, up to 10. That is this one here. And then let's go ahead and connect them together. And again, it does go through 0, 0 because we have nothing in our bowl at the beginning when we start to cook, right? We have nothing in our bowl, and then we go ahead and put information in. So this is our graph for this situation. Now, the last thing we need to do is we need to go ahead and we need to show on the graph, if I have 7 cups of flour, how much honey is needed. 7 cups of flour, how much honey is needed? Okay, so we have flour, which is 17. And flour was my y value, my y stuff. I'm going to write that a little bit different. So that was my y. What I'm going to do is I'm going to take the 17 flour and I'm going to put it into my equation. Okay, so right now I'm just writing down the equation, y equals 2 over 9x. And so again, remember, I'm going to take my y and I'm going to put it into my equation. So my flour was 17. We have 2 over 9x. And then remember, x is how much honey. That's what they're trying to find out. How much honey is needed. So how do I go ahead and how do I solve this? How do I get x by myself? We're going to divide by 2 over 9. Grab your calculator. You're going to need it. And then do 17 divided by 2 over 9. And what do we get? We get 76 and a half is our x. And what does that mean? We need 76 and a half grams of honey. Right? So they said if I have 17, so if I go over to 17 cups of flour, so 17 is right now it's not on my graph because my graph is a little bit smaller. But if we were going to go ahead and solve or answer this question, we can go ahead and just put it into the equation and then find out how much it is. So I need 76 and a half grams of honey when I have, so I guess I can add that on there. When I have 17 cups of flour. So Baker does this all the time. So we do have a backside for card number 2. Right now, we're going to go ahead and skip this right now. We are going to come back to it later. So what you need to do is you need to go ahead and take this page. You're going to fold it hamburger style, and it's going to be taped on page 24. So make sure that gets in there because you can actually use it later on in your quiz and test. And we do have a quiz later on this week. So make sure you have it done. So remember, a proportional relationship has an equation like this, which is the y equals kx, where k is the slope. And remember, a proportional relationship goes through 0, 0. The other thing that we need to understand is what is called a rate of change. A rate of change is also a slope. It is how the y changes when x increases by 1. So this is actually kind of like our money where we had $8.50 over 1. This is what is considered a rate of change. Rate of change has the bottom of 1. It's still a slope, and it still tells us what we're doing. All right, so remember, we're talking about proportional relationships. That's what we're looking for. We went ahead and scaled, and we labeled axes to go ahead and graph that proportional relationship. That was our goal for today. So we are going to go ahead and do practice problems, lesson 3. And we're going to do numbers 1, 2, and 3. And then make sure you put into Canvas. All right. Have a good day. Thanks. Bye.